Hello everyone. Today me, Rujula, and my team Asit and Soham are here to present our project SNEAKAIDS. The outline of our presentation today will be as follows. To give a brief introduction about our project, today 285 million people are estimated to be visually impaired worldwide, and most of them require assistance to navigate in unfamiliar places. So, to make this a little easier, we are introducing smart shoes which will aid the visually impaired while walking by detecting obstacles in the way. The purpose of this project is to make design a smart assistive shoe to get rid of canes, to replace canes and make people more independent. The literature survey that me and my team carried out for this project is depicted in this table. Gap identification. So these days, to detect obstacles for visually impaired individuals, canes or guide dogs are used. Guide dogs are not very reliable, and canes are not portable. They cannot be bought into trains and buses and moving vehicles. So to overcome this, we are suggesting a shoe that can be wearable as well as lightweight. So the shoe presents easy navigation and it is also user friendly as well as cost effective.
Our problem statement is basically to develop a microcontroller based electronic aid for visually impaired that will assist them in navigation and also to replace the canes that are not as portable as the proposed system. Proposed methodology. The following block diagram gives a basic idea of the working of a project. The ultrasonic sensor transmits and receives ultrasonic sound waves for a period of 10 microseconds. When an object approaches the sensor, electrical signal to microcontroller is sent, which then calculates the distance and performs comparison operation with a threshold value that is 35 centimeters. When the distance is less than 35 centimeters, the microcontroller sources 2 volts to electronic buzzer to produce sound, which in turn alerts the user. Components required: Arduino Uno controller to control the system, ultrasonic sensor for object detection, a 2-volt piezoelectric buzzer to alert the user, and a 12-volt battery power the control system. We have used the Proteus simulation software to showcase the simulation of the system. Impact analysis. The positive impact of a project is that it will be able to provide aid to the visually impaired with object detection, and also being lightweight and wearable will replace the probability portability issue of the canes. The negative possible impact might be the discomfort caused due to improper fitting of the circuit. It can also produce heat due to large power dissipation. Following are some responsibilities and ethical practices being followed by us during this project. To take responsibility of the work being assigned, show fairness to all the colleagues and their work, to follow proper engineering practices in circuit designing, to avoid conflict wherever possible, to take moral responsibility of the mistakes being committed.
So continuing on, so system implementation. So this is the circuit. I will be explaining it. On the right, we have used an ultrasonic range sensor which will sense the obstacle. The pod attached to the left of the sensor is used for simulation purpose to increase or decrease the distance. The ultrasonic sensor is connected to the Arduino boards 8th and 7th pin, while the buzzer is connected to the 9th digital port pin of the board. Now I will show you the simulation of the circuit. So this is the circuit. So when I run the simulation, the virtual terminal shows 40 centimeter. This means the obstacle. This represents that the obstacle is in 40 centimeter from the sensor. When I decrease the port value, the distance will also get reduced, and the buzzer will turn on as soon as the distance is below 35 centimeter. That is the threshold distance. As you can see, the buzzer has turned on. Back to the presentation. This is the PCB design of the circuit, and this is a picture of the same circuit which I just simulated. You can see the buzzer. It was clicked when the buzzer was kept on. Conclusions. So the sensor effectively, uh, when the obstacles that are closer to 35 centimeters are successfully detected, and the user is informed through the buzzer. In future, we would like to equip this system with voice notification, tracking, and waterproofing. These are the references we followed and read. So here we come to the end of the presentation. Thank you very much.